By the end of this video, you will be able to apply the laws of logarithms to simplify complex calculations. Did you know that the most powerful earthquake ever recorded was the Great Chilean Earthquake of 1960? This historic tremor that left many people homeless and caused much devastation had a magnitude of 8.5 on the Richter scale. The Richter magnitude scale is the most commonly used standard for measuring the strength of earthquakes. It was developed in 1935 by Charles Francis Richter. He devised this simple formula to help calculate the magnitude of an earthquake on the Richter scale, which is denoted by the variable m. Let's use this formula to calculate the magnitude of an earthquake when delta is equal to 1 and A is equal to 8,650 times A naught. But how can we isolate m, the exponent of 10, from this equation and find its value? The laws of logarithms can help us simplify complex calculations like this one. Let's see how. First, let's take the log of both sides of the equation. Now use the laws of logarithms to simplify the right-hand side of the equation. By using the product law, this simplifies to log of A naught plus log of delta plus log of 10 raised to the power m. Next, put in the value of delta and simplify log of 10 raised to the power m using the power law. The log of 1 is equal to 0 and the log of 10 is equal to 1. Thus, our equation simplifies to m is equal to log of A minus log of A naught. Now put in the value of A and apply the product law again to this term. These two terms cancel out, leaving m is equal to the log of 8,650. Simply find the log of 8,650 using a calculator now. Thus, the magnitude of the earthquake at delta equal to 1 and A equal to 8,650 is 3.94 on the Richter scale. That was easy, wasn't it? Time for an exercise. For the given equation, find the value of y. First, let's take the log of both sides of the equation. Now use the laws of logarithms to simplify the right-hand side of the equation. By using the product and quotient laws, this simplifies to log of 8.97 cubed plus log of 3.95 squared minus log of 15.37 raised to the power 1 over 3. To further simplify, apply the power law to all these terms. The powers will simply multiply with the logs of the bases. Next, calculate the logs of 8.97, 3.95, and 15.37 using a calculator. The log of 8.97 is equal to 0.9528. The log of 3.95 is equal to 0.5966. And the log of 15.37 is equal to 1.1867. Further simplification of these terms gives us log of y is equal to 3.656. Now that we have the value of the log of y, we can use it to calculate the value of y. We do this by taking the antilog of both sides, so that only y is left on the left-hand side. Calculate the antilog of 3.656 using a calculator. Thus, y is equal to 4,528.98. Good job! Let's summarize. Logarithms can be used to model situations in the real world. The measurement of the magnitude of an earthquake is just one example. Laws of logarithms can be used to simplify complex calculations by changing multiplication into addition, division into subtraction, and powers into multiplication. Can you think of any other instances where we use the laws of logarithms to simplify complex calculations in real life? Some examples for you to research are compound interest, the pH value of aqueous solutions, and the intensity of sound.